A train regulator checks the times that 50 trains arrive late at a station and records the results in the table shown. Drawn a frequency diagram to show his results. So we got here the time, t minutes, and the frequency, and these split between 0 and 1 minute, 1 to 2, 2 to 3. Therefore, between trains that arrived between 2 to 3 minutes late, we were 5. Between 3 to 4 minutes late, 8, etc. So what we're going to do is draw a frequency diagram to show his results. So I'm going to use GeoGebra to do that. So here we have the original table that you've just seen. If we click here, we can see a frequency diagram. So along the horizontal axis, we have the time. We have the time in minutes, and then up the vertical axis, we have the frequencies. Remember to label your axis. And so if we click here, we get the bar chart or the frequency diagram. Okay, so for between 0 and 1, it goes up to 1. Between 1 and 2, it goes up to 2. For example, between 4 and 5, it was 9. 4 and 5, it is 9. Okay, so this is the frequency diagram to show that information. Right, he then groups the data into the following classes from 0 to 4, from 4 to 6, and then from 6 to 12. Draw a frequency diagram and a histogram for this group data, and then comment on the representation. So, if we're grouping the original data, so there's the original data, we now group it into a table like this. So the new table will look like that. So from 0 to 4 will be 16. That's 1 plus 2, which is 3, plus 5, which is 8, plus 8, which makes 16. And then between 4 and 6 will be 9 and 7, which is 16. And then between 6 and 12 will be 6 plus 4, which is 10. Plus 3, which is 13, plus 2, which is 15, plus another 2 is 17, plus 1, which is 18. So if we now draw a frequency diagram for this, okay, so this is the original one, so let's just unclick that for a minute, and what we get here is the new frequency diagram. We can see that this is actually very, very misleading. It's not showing very much difference between anything if we draw a frequency diagram. Now it might be wanted to draw it this way because these would be acceptable, these might get a written warning, and this would be considered to be unacceptable. There might be different reasons for grouping. However, this diagram doesn't really represent the data, it is a little bit misleading. So the frequency diagram gives a misleading impression of the original data, so it would be better to draw what's known as a histogram. Now for a histogram, it's the class width, the height of the bars are given by what's known as frequency density. So here we have a new table, so it's the same table as above, time and minutes and frequency, and then 2 extra columns, and we've worked out the class width. So from 0 to 4, which is 4, from 4 to 6, which is 2, and from 6 to 12, which is 6. Now to get the frequency density, we do frequency density is the frequency divided by the class width. So this cell here, for example, this cell here will be 16 divided by 4, which is 4. This cell here would be 16 divided by 2, which is 8. And the final cell would be 18 divided by 6, which gives me 3. Now if we now make these the height of the bars. So going back to this, okay, so we're just going to click this one, and we'll click this one. This looks doesn't give such a misleading representation of the data. However, some of the data meaning has been lost because we grouped it, but we can now see that the data has been represented a bit more fairly. For example, and what it means is that the area underneath, by doing the frequency density, the area underneath in each bar, the area represents the frequency, so the area is proportional to the frequency. So one of these squares here, for example, will represent 2. You can see that there, not so easy there. Okay, so let's just see if this one, so that's 1, that's 2, so that'll be 6. 6 times 2, which is 12, is the bottom bit. There's another these two here will represent another 2, it's 14. These two here will represent another one, which is 16, and then these two here would represent the other 2, which make the frequency up to 18. So that the area underneath is proportional to the frequency. And compared with the original data, there's the original data. Doesn't look, it's a bit more representative. Okay, there's the original data. There's the histogram on top. Okay, compared with this one here, which doesn't really represent the data at all. So this GeoGebra applet I will put in the notes of the video. Just check the link in the notes of the video. This gives a better representation of the original data, but some of the original meaning of the data has been lost when the data has been grouped. So it is better to draw a histogram rather than a frequency diagram if you start grouping the data. Okay, so this has been a video to show you how to draw frequency diagrams and histograms. I hope you've understood, and I thank you very much for watching.